Non-intrusive inspection as an alternative to internal visual inspection. Many years ago, exploratory operations were quite common. Fortunately for us, the medical profession no longer needs to open us up to diagnose what's wrong with us. They now have advanced imaging technology like X-ray, MRI, CT scanning, and of course, ultrasound. Really? Internal visual inspection. It is still common practice to perform internal visual inspections, IVI, of pressure vessels. This can only be achieved when the plant is shut down. Some vessels have to be opened to perform essential maintenance or to replace catalyst materials, but there are many other instances where IVI can be replaced with non-intrusive inspection. Introduction to Non-Intrusive Inspection, NII. Non-intrusive inspection, NII, is a process in which advanced inspection is aimed at replacement or deferment of an internal visual inspection. Planning and evaluation is carried out to ensure that the inspection meets a specific set of criteria. It is not an ad hoc inspection that makes some use of externally applied inspection techniques. The process involves assessment of the plant, identification of suitable vessels, inspection that can be performed at any time, data analysis, justification for NII versus IVI, and prioritization of the vessels to be inspected with an aim to reduce shutdown requirements. The NII approach follows the Harwell Offshore Inspection Services HOIS recommended practice for NII. Sonomatic is a member of HOIS. This approach is published as DNV RP G103. This document was developed with input from many of the world's leading oil and gas companies and is widely accepted internationally as representing best practice. NII Stage 1 Assessment. Recommended practice is followed to determine if the vessel is suitable for NII. The initial assessment defines the inspection requirements, ensuring that any degradation with the potential to threaten integrity is identified. These requirements, for example, detection capability, are then defined. When a vessel has been selected, a flowchart guides the engineer through a decision process that establishes the suitability of that particular vessel for NII. Consideration is given to previous inspection history, the history of other vessels in similar service, and if vessel entry is scheduled for other reasons, resulting in a decision as to whether NII is appropriate. If it is determined that NII is appropriate, an inspection plan is developed. NII Stage 2 Inspection Planning. The work scope takes into account what type of inspection is to be utilized. Type A, where no degradation mechanism is expected. Type B, where a degradation mechanism is expected but with low to medium progression. Or Type C, where a degradation mechanism is expected and with medium to high progression. All inspections are item-specific and are targeted to detect expected degradation mechanisms. Once the work scope is defined, the inspection can take place. NII Stage 3 Inspection Enactment. The inspection activity can take place at any time whilst the plant is operating. Inspection techniques include corrosion mapping, time of flight diffraction, creeping headwave inspection, and multi-skip, as well as manual ultrasonics and radiography. Multiple teams can be used to shorten inspection timeframes if required. NII Stage 4 Evaluation and Analysis. A thorough review of the inspection findings is essential to ensure that the inspection process has been effective. The review checks that the inspection work carried out was to plan and also assess decisions regarding anomalies, etc. If there is a deviation to the plan, the HOIS document provides guidance on non-conformances. NII is often undertaken with less than 100% coverage. Statistical analysis of data obtained can be used to determine if coverage was sufficient or if additional inspection is needed. Extreme value analysis can also be applied. The inspection results are then extensively analyzed to determine the actual condition of the component and to identify any defects that may require detailed analysis, such as finite element modeling. NII Stage 5 – Justification. The justification reviews the project outcome and confirms that the NII achieved meets the requirements for a full replacement or deferment of IVI. The interval assigned to the next inspection is validated or adjusted in accordance with the recommended practice. The justification report is then used to update the information in the risk-based inspection system. Cost comparison between IVI and NII. As the inspection can take place at any time outside of shutdown activities, NII has significant advantages over IVI. The most obvious being the revenue from continued production. If any defects requiring remedial action are identified, that action can be planned ahead of the next scheduled shutdown. If no significant anomalies are detected, a justification based on sound data can be made to either defer IVI or to replace it entirely for a period of years. Summary and conclusions. Successful implementation of NII as an integrity management tool depends on a multidisciplinary approach, including corrosion engineering, inspection engineering, and mechanical integrity. A wide range of sophisticated inspection techniques are available to ensure a high degree of confidence that degradation of concern is not overlooked. It is often possible to perform NII when there are a reasonable number of previous inspections or a comprehensive corrosion risk assessment has been undertaken. NII offers the potential of significant cost savings compared to IVI without compromising integrity. Approaches to NII assessment and planning have been developed and proven in practice worldwide.